So can we run this on Databricks as well? Right, we can run this on Databricks, right?
So this code, Databricks doesn't require this code. This is for setup only.
No, no, no. This is for local setup, right? We can run this. We can practice everything on cloud as well, right?
Yes, yes. If you have access to cloud, that's the
That is
only.
what Databricks,
Yeah.
right?
Yes, yes. Either Databricks or local, you need to have access to only one environment. That is
So
good enough to use the
can
cloud.
I share my screen for a minute, please?
Yeah, please go ahead.
So this environment will suffice, right? The Databricks environment, what is displayed, because I was able to create an account.
But this is your, I think, trial account which will expire in 7 days. But this is fine. For today, it is fine. You can try this community edition later on.
Okay, let
Okay,
me see
now
if.
you go to on the left hand side, you can see the cluster symbol, right? And it's just below that. Just below that. Ah, no, no, not this one.
So
Second one, the second one, second floor. Ah, that is workspace. Create workspace. On the right hand side, you can see create workspace.
which should I select, sir? Quick start or custom?
Quick start, quick start. Quick start will have the default parameters and get started. But this may ask you for AWS credentials.
Yeah, I have configured that. I mean, I have those credentials.
So then go ahead, please configure it. But if it is locally working, then why you are using it?
Oh, okay. And I just wanted to ask, like,
Yeah, yeah. But it will increase your AWS billing as well if you have a quota or if you have a corporate account, that is fine. So go ahead with that. Do a setup, please.
so do I need to check this? Oh, I don't have any data in S3.
Storage cost is not much, but the computation cost would be much when we are trying some complex commands.
Oh, okay, okay, sir. Then I'll probably use the local account. The
Okay. I'm facing trouble with the Teams here. What's wrong with Teams? Jesus. I'll show you. Okay, I click on this. It will open up.
Does it like take forever to load? Or if that's the case, then I think you can continue and browse it. Even I am fixing this for a couple of weeks, but when I try to join in the browser, it works. Internet is also working for me. So right. It takes forever to realize the problem. I think that's an issue from Microsoft itself.
Guys, I'm trying to restart my machine. Teams is taking a lot of time to reload. I mean, load into the machine. Suddenly it shuts down, and then after that, it's not loading up. So let's continue with the class. Okay. So I hope somehow you have done some little bit practice around PySpark, and at least you are able to set up the environment and you are able to create a Spark context. Now, what is next? Okay. So to get started, I think why PySpark is the like next set of or next standard of a programming is that uh, many people you are aware about the recent developments from Snowflake side of things, right? Snowflake and the Snowpark, etc. So Snowpark is a distributed computing platform that supports the PySpark kind of programming. Okay, and normal Python programming is not designed to scale. That's why in a distributed, and why distributed computing is required is that at least you can expect few GBs of data from any environment in any kind of enterprise scenario. So that is why there is a continuous push now that people should learn PySpark. Otherwise, it's bit difficult for the organizations. Okay. So in my experiences, at least I have seen, we are trying to push people from Python to PySpark. And not only for data processing, it's including the machine learning as well. So it has limited algorithms that Databricks or that PySpark just supports, which is what I was looking. Okay. I don't know why it is coming like this. It goes in a forever mode. There's something wrong, yeah.
Starting. You continue the class and I will see something.
Yeah, you check. Okay. So, yeah, I was talking about the PySpark programming, right? So, what are the things we can do using PySpark? One is large-scale data joining from different environments to create a consolidated data set. Data wrangling, data cleanup, all those things we can do. We can do machine learning, we can do data pre-processing, we can do machine learning deployments as well, right? And also at the same time, we can do something like PySpark job orchestration. That is also very, very important. Okay. So some of you maybe you will be part of development team, or you will be part of maybe architecting the development or architecting the processes, how the data should be processed, how the machine learning pipelines should be created, right? So maybe I assume that some of you may be in the leadership position in various organizations. So you will be like you would be asked to create maybe data pipelines or create architectures, how the data would be processed, and so all those things, right? So to get started on this, you first have to know the Spark concepts, and also we can share my. I can share my
Yeah, you
screen.
can share your screen.
It will work.
Yes. I mean, it's not sharing it. You can start sharing it.
I can start sharing. Just a moment.
And then screen. And then select it and share it.
Yeah, you can see my screen.
It's showing here. And you can use a microphone. This one itself.
Okay, fine. So this one I can mute it, right?
Yeah, it's muted.
It's muted.
Yes.
I'll be using that one.
Yeah.
Okay, fine. Thank you. Okay. So Yeah, I was talking about PySpark programming and why it is different. So we'll now learn the RDD concepts, the uh, why RDD and what are the nuances of RDD. Did I cover the theoretical aspects of RDD before?
Yes, sir. It's a resilient distributed data.
Resilient distributed data set, but any other concepts relating to RDD, did I cover that before?
No.
No, right?
We got
Okay.
the introduction.
So let me first introduce the theoretical concepts little bit around the RDD, and then we'll do a practice and we'll learn how it works in practice. Just a minute. So let's look at what is the internal working. So as we know that similar to Hadoop, Spark also uses master slave architecture. Now, one master, many slaves can be designed in this architecture. And what is central? The central to all those computations is the driver. Driver is the central coordinator. Now, this driver and executor programs, it runs its own Java process to execute the tasks. Okay. Now, this is the to get into little bit details. These four things that we discussed last time also, what is Spark application, what is a task, what is a job, and what are the stages. There are three components of Spark: driver, executor, and cluster manager. The role of a driver is to do job scheduling and negotiations with the cluster manager in terms of releasing and creating applications and containers which can hold the processed data. Okay. And the driver also responsible for storing the RDD based informations. Now, if you are creating one resilient distributed data or RDD, now this RDD information, again, it's the driver's role to store it and release the metadata related to it. The role of executor is to store computation results in memory. And this executor basically confirms or creates one DAG. So it is called directed acyclic graph, which you saw in the last class also. Now this DAG, it's basically stores the steps of computations. Starting from reading the data, once the data read completes, then what happens to the processes and how it executes multiple steps to complete the entire pipeline. Now this entire pipeline, it can be simple data pre-processing, feature engineering, do one-hot encoding or some transformations of the data, or it can be execution of any kind of machine learning algorithms as well. So the role of executor is perform all data processing related tasks as well as computation related tasks. And finally, the cluster manager, it is responsible to maintain the healthy or health of the cluster. It is responsible for again connecting or communicating with the driver to get at least an idea about the computation and like secure some resources which can be again like given back to the executor to perform the tasks. So acquiring the resources from Spark cluster and maintaining the health of the entire cluster is the responsibility of a cluster manager. So those are three important concepts. Now, coming back to the runtime architecture of a Spark application. Now, what happens first? The driver talks to the cluster manager and negotiates for the resources. Resources, as in suppose you are writing, let's take simple binary variables you have to create, or dummy variables you have to create, which is also known as the one-hot encoded vectors you have to create from the data. Now, if you are creating one-hot encoded vector for customer ID can be millions. So you are creating million columns by taking unique values of the first column itself, right? Which is a very cumbersome process, and it takes a lot of time to create those features. Now, for that, you need more resources to process this particular task. Now, what happens in this standalone cluster? So here, like this cluster is a fixed cluster. It's not an auto-scalable cluster, right? So what is auto-scalable cluster? I'll explain that little later. Now, at this moment itself, if your cluster is a 3-node cluster or a 5-node cluster, it's limited. The cluster cannot be extended automatically, right? For that, you need to have a cloud access. Now, even on Databricks also, you can click on this auto scale on. When it reaches 90% of the threshold, automatically it spins up another cluster and it directs the works or the computation needs to that particular cluster and extend it, right? So like that in EC2 also, EMR. So EMR also you can extend and you can make auto scalable on. So cloud, it is quite easy to spin up the clusters when the existing cluster threshold reaches up to 80% or 90%. That threshold you can manage and you can set that threshold, right? However, in a standalone machine like a local setup or a fixed cluster, so this community edition of Databricks, it's a fixed cluster where autoscale is not available. You have only one cluster, 3-node cluster, so you cannot extend that further. Right. So in those fixed scenarios, if the task that you are going to execute, it requires more resources, then I mean, automatically that will be scheduled and it will be taking time. So long running processes would be running on your machine. Now, if you have patience, you have to wait, or you have to kill the processes. These are the two options available, because you can't just like increase the scalability here. Now, during this communication, suppose you want to give, let's take dummy variable creation for customer IDs. It first computes how many resources would be required, or what is the size of resource would be required. Now, based on that, the timings would be scheduled. So cluster managers launches these executors on behalf of the driver, and executors register themselves with the driver itself. Now, when the job enters the driver converts the code into a logical graph. So that is called a DAG, which is like directed acyclic graph, which remembers or which basically stores the exact steps that are going to be performed. Now, in suppose let's take you have written an ETL logic, which is usually typically that's in a Spark. Yeah. Suppose you have written an ETL logic that is using Spark SQL, right? Or maybe you have written those logics long back, right? Now those ETL logic, you cannot think every time and write it from scratch. So you would like to migrate this logic to somewhere else, right? So now what is the best way to do that? The best way to do that is if you think that your ETL logic is applicable across different data sets, verticals, and you have one set of ETL logic that works everywhere, right? So you can create one DAG, and this DAG you can pass it to other teams. So one logic, that's a DAG, and this DAG you can pass it to anyone else, and they can take it for others, and they can run it. They don't have to develop the code from scratch, right? So the DAG remembers the exact code and code flow, which is easier to execute in other environments as well. If you want to optimize the DAG, also you can do that. Now, optimization of a PySpark that we can cover a little later, because you have to understand each and every function what it does. So as an example, let's take a repartition versus coalesce. So there are two functions, that is, one is called coalesce, COALSCE, and the other one is called repartition. And before that, you need to know what is repartition, right? So let's just see the basic difference. We can do some experiments on an RDD to see what is the difference and which one is the optimal under what situations or what circumstances. So this coalesce function, it uses existing partitions to minimize the amount of the data that can be shuffled, right? So in the map reduce program, I told you when you get the input data, first you have to do a map. Now mapping layer will assign the default values to each of the tokens, like in a word count program or any other program. First, it assigns the default values. Now it will go to the shuffle stage. Similar tokens or similar elements should be grouped together. And the shuffle stage will be the place where it takes a lot of time, because data shuffling, I mean, one is the mapping stage, which doesn't take much time, but shuffle stage takes time. Then after that, reduce step. In the reduce step, you have to basically perform the operations like count, average, etc. You have to sum it up. If it's a sum, you have to compute the average, right? So this coalesce function, it basically uses the existing partitions and existing partitions to minimize the amount of data that need to be shuffled. However, repartition, it creates new partitions and does a full shuffling of the data. So which one to be used and when? Now, this is a debatable topic. And for some people, the coalesce works and it takes less time. For some people, repartition takes less time. Now, there are various dynamics to this. Dynamics could be, let's take you are doing shuffling using one categorical variable or two categorical variables. Your data set has a few numeric variables. That is one scenario. The other scenario is your bins are very less for a categorical variable. Let's take high, medium, low. Only 3 bins are there. Versus there is another data set where you have like countries, 20 countries are there, right? So kind of a cardinality in the dimensions or cardinality in the string based columns also sometimes play a role in deciding which one is faster, whether repartition is faster or coalesce is faster, right? And these two programs, it does the exactly same thing. Okay, now this is one. There are other functions. For example, whether you will be doing collect versus, there is something called collect versus show. Or collect versus take. Which one to use? Which one is optimal? Is collect optimal, take optimal, or show optimal? Collect shows the content and structure and metadata, all three, right? Like for example, you can do df take 5. So it will show you 5 records from this data frame. Now this data frame is nothing but this is an RDD, right? Which can be used to show the content structure of the metadata for a limited number of rows or for a very large data set. You can replace the take with the show also. Take would be a row format, which is like each row would be taken as a key and a value pair. So key would be column header, value would be that value corresponding to the record that we have seen. It's a take is basically columnar representation of the data. However, show is a data frame view, which takes a tabular view, rows and columns, both it takes into consideration, right? What is collect? If you are doing some kind of operations, right? So as I said in the previous session also, there are two kinds of things you can do. One is transformations, one is actions on the RDD, because you cannot modify the RDD. So if you want to do a group by, after group by, what happens? In a regular pandas related pivot functions, right? Pandas pivot function you are aware about how it works. So you can take one row variable, one column variable, or multiple column variables. Then you can apply a function over there. It shows a result to you, which means by default it shows a display, right? On a RDD, if you want to do the similar kind of operation, it doesn't show a display by default. Why? Because Spark works on the concept of a lazy execution, or it is called lazy evaluation, which means Whatever group by statements you are writing on an RDD, right? It remembers. The DAG takes this into account, but it doesn't fire the query there. And something fine, filter, anything that you do, it is fine. The moment you do show or take or collect, then the execution happens. Right? So you perform some group by or simply descriptive statistics. You did descriptive statistics, and after that, if you do collect, then the execution happens because the user wants to see the result or output. That is why it is called lazy evaluation or lazy execution, right? So similarly, there are certain concepts which will be like we have to evaluate based on different kinds of data sets, and we have to do practice to figure out why this is taking time versus that one is taking less time. So that's why it's part of your optimization process. So you have to optimize which functions are working, which functions are little slow in depending on situations. Now this physical execution of plan with a different set of stages also, that is also part of your DAG. Small execution units known as the tasks. And again, the tasks are sent to the cluster. This is also part of your DAG, right? And these executors execute all the tasks. Definitely, the driver program monitors the executions that run. And sometimes if it fails, what happens to the DAG? The DAG stops over there, right? With a status as failure. But it is not going to return what happened to the and where exactly the failure happens. In your Python program, you can introduce maybe something like a logging mechanism to understand where it fails, at what stage it fails, right? But here you cannot do that. Because this execution happens at a DAG level. There is no way to identify where it breaks. Again, you have to go to the DAG, click on it and figure out which step it broke. But why it broke, you will not get. And messages are, now they have streamlined the messages. Initially, it was very cumbersome, difficult to read even the messages, why this code is not working and all. So, but today it is a little bit easy to figure out why it failed or why it broke. But you will not get a clear error message that because of this, it broke, right? So then in this case, if it fails, then you have to go to the DAG, check the code, expand the plus sign that you used to see, and see where it broke, which step, what was the error. Then you click on that, it will take you to the logs. So in the UI, you will find towards the last, there is a call, there is something called a log. Now this log is nothing but the log4j, which again prints where exactly, which step exactly it fails. All the tasks by tracking the location of a cached data based on the data placement. So all the tasks by tracking the location of the cached data. So RDD is always by default, it is cached. Now, should we purge the data or should we cache the data? Right. So basically, if you want to purge the data, so there is a method called persist. So you can do RDD persist versus RDD cache. Persist you can do if you don't want to use that every day. Suppose you have to send weekly reports, you can do persist. If you want to do every day, you want to work on this and you don't want to import the data every day, you can do a cache. So because frequently you are using. So after you do the whole work, finally you can just do rdd.cache. So the RDD would be cached and next day you can just read it back once again. But if you do persist, then there are two options. Either you can persist it on the driver program itself, or you want to persist on a location. So any permanent location, it could be on any drive or on cloud location. You can persist it. Okay. And again, you can read back the RDD in a faster time, and it takes less time to read it. And again, you can go ahead with execution of your tasks. Cluster manager, we already discussed what is cluster manager. Deploy mode in Spark. So there are two kinds of possibilities in deploy mode. One is cluster mode and client mode. Spark in client mode is basically the driver component is running on the machine where the job is submitted. Cluster mode is the driver is not in the local machine where the job is submitted. That's the only difference between client mode versus cluster mode. In a client mode, job submitting machine is expected to be near the Spark infrastructure. Otherwise, there will be latency in the data movement over the network. Similarly, in a cluster mode, job submitting machine is expected to be nearer the Spark infrastructure. Otherwise, again, latency also will be there in data movement. Okay, so that's why there are two kinds of options. And now this one also standalone cluster we discussed. Spark on standalone also we discussed. IARN also we discussed in the previous thing. This graph in a different way we covered in the last session. This is your deployment, client mode, and this mode. Now we'll go to RDD. Yeah, so RDD we know that it's called resilient distributed data. Resilient because it is fault tolerant. Distributed because it is distributed across the worker nodes. And dataset, as the name suggests, it's a dataset. There are three ways to create an RDD. One is using something called parallelized collection, which means if I just go to this, cluster is on, Spark session, initialize the application, just check the health of the application, it is up and running, right? Now here, I will simply read a dataset using pandas. Now this becomes my regular data frame. Just do data.head. Sorry, 5 records. It's my regular data frame, right? And here I can just see header equal to none. So I have almost like 8 columns over here, which is fine. Now, if I want to create an RDD out of it, I have to use parallelize function, right? This is one of the way to create an RDD. The three ways to create RDD. One is executing a parallelized collection, referencing a dataset in external storage system, which could be H5 or Hadoop distributed files, or it could be a Parquet file. It could be anything. And third way is create from other RDDs using transformations. So on a specific RDD, if you're just applying some transformations, now that will also create another RDD. So there are three ways to create RDDs. Okay. Now in this case, this data is simply in pandas data frame. And how to know that? You can just simply do a data.info. So it is a core pandas data frame having 8 columns and 209 entries, column types, etc. So float 7 columns, integer 1 column, etc. So on and so forth. Now what I'll do, I will simply do RDD creation. Now here just type DA. This is a parallel collection RDD. Now remember, this is my first RDD. Okay. Before this, I did not create any RDD, right? I did Spark application creation here, then did a pandas data frame read. And this is my first RDD which I am created. So now you can see RDD that is associated with a number, right? This number basically nothing but if you run it 20 times, this number will be incrementing every time you do another kind of execution. So we ran it once. Now this is available. Now, if I want to run it once more, what happens? This updates to 1. Did that happen? Ideally, it should change, right? Why it did not change? Any ideas? Because I did not update this one. I just print it. Now I will change this one. And again, I will create parallelize data set, data, and store it in DF. Now this time it will change. You can see the one here, right? So what does this mean? Now we have 2 data frames in 2 locations. RDD 0 is existing, RDD 1 is also existing. right? Same data, it is being stored as two collections. We cannot overwrite because when we do parallelized data, it creates partitions and randomly it creates partitions and stores it in the worker, distributes amongst the worker nodes with default replication. What is the replication? Repetitions, right? So what happens now? It uses backend as Hadoop for storage the data. Hadoop, how storage happens is that you have data blocks. Data blocks resides within the data node, right? Each data block has certain limitations of storing certain values. That is currently it is 128 KB, right? And if the data block fills, it skips to the next block. That's how the distributed storage happens with the replication. The replication is there, so same number will be stored in multiple other data nodes as well. The reason is that you have to get back quickly the data. That is where the replication happens. You can increase the replications to support massive parallel processing, right? So what happens after this? Now this is DF. You have imported the data. You have created one RDD. Now you can do take on this. We did not specify a number. It requires a number. So let's take 2. It's a columnar storage. Take. Just click on this. But take only takes 2 values. Okay. Now if I do show, RDD object has no attribute called show. Show is applicable for data frames. Show is not applicable for RDD. Then you do again take. Okay. Now this take has 2 values. So what is this? This is first record. This is the second record. It gives you the 2 numbers only. Now, if you want to extract the information from this RDD, then you have to use collect. Now, when you do collect, it gives you the column numbers 0, 1 up to 7. So 8 columns are there. Okay. Clear now? Now data.head, it's a pandas function, which again tells you the columns and the values. Now, if I have to use the same RDD as a data frame, so there are 2 constructs within Spark. You can either use a Spark data frame, you can either use a RDD. RDD is the default object creation. Whatever data you import, by default, it gets converted as an RDD. But if you convert that to a data frame, it is easier for you to apply additional functions. There is a large group of functions which data frame supports. Some of the functions which RDD doesn't support. That's why always, if you want to work on the data wrangling, then always you should convert the RDD to a data frame, Spark data frame. Okay. And Spark data frame, how do you create it? So let's look at. We'll create RDD creation as a separate application here. Just check the application if it is working. Yeah, it is working. Now here, just manually feeding some values and you can create one data set. Let's call it RDD. Now, when you do RDD.show, you'll be seeing a tabular function over here. Now, what happens here? It's a data frame. It's a Spark data frame creation. Okay. Now, this Spark data frame creation, you can do even that. So earlier, what data I have used? Seeds. Seeds equal to Spark dot create data frame and you do data. Now you can do seeds.show. You can see now remember on the show, we applied on RDD. It was showing error, right? DF is RDD, right? This DF object is an RDD. Using this data itself, we parallelized and we created a data frame DF. But this DF is nothing but it's an RDD. On RDD, you can just do take function and collect function. You cannot apply show function. So show will not work here because it's an RDD. That's one of the way to check whether the object is Python object, Spark object, RDD, or Spark data frame. Okay. Now here we are using create data frame. It's basically Spark data frame. Now the question is Spark data frame is RDD? Yes or no? Is it an RDD? Basically seeds, right? Is it an RDD? It shows it's a data frame, right? But each data frame an RDD? No. By default, yes. Right. So data frame is a wrapper on top of RDD. Right? Why data frame is a wrapper?
Can you explain that again, please? How RDD is not a data frame?
No, I said RDD is not a data frame, right? But data frame by default is RDD.
Okay.
Okay. Why? Because data frame, we are trying to convert and write a wrapper around RDD to create a data frame because we want to apply additional functions on top of it. We want to apply transformations easily on top of it. That is why we are creating a separate feature by running a wrapper. So this wrapper is called create data frame, right? On the data. This we can do maybe seeds equal to Spark dot this is create data frame Spark context. So using Spark context dot parallelize data. So now one is data frame, the other one is RDD. Okay, the limitation that's what I'm trying to explain is that the limitation here, if you just do seeds.show, it is not working. Why? Because this object is now overwritten by this object. The name, right? We can give a new name to it. Now this show would work because this show is on the seeds, which is a data frame. If I change it to seeds 1.show 5, it will not work because this is an RDD. This one is an RDD. Okay. So please remember those two things. That's fine. Just ignore it. We'll keep seeds.show. Is it clear? Any questions? Is it clear? Any questions?
Just maybe it's, I don't know whether it's the right question. What's the difference between a normal data frame and an RDD?
RDD, when you are using basically RDD is nothing but a parallel collection. So you are creating RDD, which is a Spark object, and it is distributed across the clusters.
Okay. Okay, got it.
This is a normal data frame. Using those sc.parallelize, we are creating one RDD, and that is a distributed data. Okay. Now, if you are using create a data frame would give us additional functions or additional benefits of writing different kinds of functions. So I'll just tell you, if we go to Apache Spark, so here let's go to machine learning, and there is a machine learning guide. Okay. So you can do basic statistics on RDD. Go to Python, right? So here you can create. No, they have changed it recently. Everything seems to be data frame. Okay, this one. So you can see the two guides here. One is RDD based API guide. One is main guide, which is a data frame based guide. Now, basic statistics using RDD, if you just look at, then the code is slightly different. Here, sc.parallelize, and you can pass any NumPy array or pandas data frame directly. You can create one RDD. Now, on RDD, if you want to run a statistics, so the statistics module you have to import, then you do a column statistics or row statistics. Then you have to pass the RDD that you want to use to compute. Now, this stores all the values and you have to use it, right? So this is RDD way of getting basic statistics. Let's go to here and we can apply it here. NumPy from PySpark mlib stat import statistics. This mat, I will remove it because I want to use either seeds is in data frame, seeds one is in RDD. So instead of this, I'll be using seeds one. Okay. Print the summary statistics. There is an error. Statistics, column statistics, seeds one. There is an error. What is that error?
So this is Iris data set, right?
This is no, this is not Iris dataset. This is this dataset you can see.
Seeds. Okay.
So seeds datasets. This is some artificial data which we have created. This is some artificial data. So I assume that here it seems to be cannot convert class int into vector. So the data seems to be integer for some columns, which is it's not able to convert that to a vectorized form. That's why this error is coming up. So if I'll keep the NumPy array here, which is already in integer form, maybe this matrix. This is an array with 3 columns, 3, 3. Okay. So let's try this one. So this is showing a column statistics. Now here we can change it to NumPy array also. Let's try this seeds conversion to NumPy array if it is possible. This is the data. Okay, there is integer, there is float, which is a combination. It will ideally work here. This is the data that we are using. And on top of it, if I'm just using np.array, this is getting converted to a NumPy array. And I will store it as data underscore 1, which is equal to this. Now this data underscore 1, I can just change it here. Sorry, I have to run this one. Why it was throwing error? Because earlier I was trying data underscore one, but it is a pandas, sorry, numpy array. First, you have to convert it into an RDD. Data underscore one is now becoming RDD, so you can give a name as data one. And here I'll change it to make it data one. So it is now giving for all columns the column statistics. The first one is printing the column means. Second one is column variance, and then number of zeros in it. Okay, so number of zeros are 5, which means each column has 5 zeros in it. Okay, so this is a way of getting basic statistics from RDD. Now here data 1 is an RDD of vectors. Okay, now similar execution if you want to do basic statistics on data frame. Now this is how it looks like. So you have to first create a data frame, Spark data frame, and then you can use the basic statistics. Here you can do correlations, you can do basic, so this starts with the correlation. Where is statistics? Descriptive statistics, where it is. Just select. This is different. It is in summarizer. Yeah. Compute statistics for multiple metrics. Here you can compute mean, standard deviation, variance, etc. And this module is called summarizer. So the point here is there are two ways of writing those Spark APIs. One is RDD based operation or RDD based API. One is the data frame based API. Again, here if you just see, let's take algorithms. Few algorithms are supported here. Let's take clustering. K-means, LDA, streaming K-means. This is for streaming data. This Gaussian mixture models. This PIC. Only few algorithms are supported here when you go to RDD based operations. Now this is for K-means model, but K-median is not there. K-mode is not there. Then other Euclidean distance or Manhattan distance, all those matrices are also not there. So limited functionality there. Now, if you want to extend it to data frame based, you can see other things also. For example, K-means you go Python. Again, here also limited, but you could do Silhouette distance calculator, you can do evaluation, you can do other syntaxes also we can see, but K-means, K-median is also not there. Only K-means are there. Yeah, K-median is not there. Bisecting K-means is there. But this is different. This is not K-median. It's quite different. Okay. So there is slight difference between RDD based operations versus data frame based operations. But I think I would recommend always to go ahead with the data frame based operations, because sometimes RDD is like a similar objects which you are like all numeric columns you want to do something, or all categorical columns you want to do something, then you should go ahead with the RDD based operations. However, that's not a reality. The reality is that always you will be getting mixed data in practical scenarios. Some columns are string, some columns are numeric, some of them are in binary. So mixed data, when you have to deal with, always you should go ahead with this data frame based operations, right? So like this ETL step, etc. Extracting, transforming, and selecting the features. This is important, and this is massively distributed. So that's why it is very, very important to go ahead with the data frame based operations. Which functions you are going to use more frequently? Probably this is for NLP related tasks like n-gram extraction, so stop word removals, tokenization of the sentences, this is going to be NLP pipeline. In a structured data scenario, you have to use one-hot encoders, vector indexers, normalizer, standard scaler, robust scaler, min-max scaler, bucketizer, and vector assembler. So those are the things which you will be using more frequently in a structured data scenario. Apart from that, there are some other functions also, but these are like having very specific use cases. Okay. Questions? Is it clear now?
Yes. Yeah.
Fine. So the next step is there is another way of reading the files also. This is a Databricks specific way of reading files. Okay. Directly you can use an URL and read external files. You can drop the files in the file storage here in Databricks, and then you can give the path to read the files directly. That is another way. Also, you can you can read the files using Databricks specified Spark format and CSV format. This is just another way of reading the CSVs. Spark.read format. This is the fixed syntax which should not change. Options. Here you can make header equal to true, infer schema equal to true. After that, when you start loading the file, you can provide a file path here. Okay. And here, let's print the DF. So what we are getting now, only the column names we are printing. It tells you the first column is itself is integer, then sepal.length, sepal.width, it's a double. So column name and the data type, it is only printing. We do a show here, df.show, you can see the data. And we can do just 5, top 5 rows. This one is nothing but some default index is being associated with the CSV file. You can get rid of at any point of time if you want, right? So now remember, this is one of the way to read the file here using Databricks format. This is a Databricks neutral format where we are reading the same file here. Infer schema true, header equal to true, but we are using spark.read.csv. This is also same file here. Result, there is no difference. Which one is optimal? Both are equally good. But the problem here is Databricks, if you are in a Databricks environment, then this would be recognized. If you are not in Databricks environment, then you have to use this. Now this file path location could change. If you are directly calling the file from S3 or from HDFS storage or from packet storage or anywhere else, a DB connection is required. You can establish the DB connection, and this part is only going to change if you want to read the file from somewhere else. Now, if it's a DB connection, then it's not going to be CSV, read.db, right? So you can see the formats over here as well. So you can do spark.read. Here you can see the options. You can read JDBC connections to JSON files. You can load JSONs, Parquet files, schema, text files, table, ORC. So these are various options that we have. And mostly we'll be using either Parquet file because in a Spark distributed computing environment, the common input file is Parquet file, which other applications will also provide you. And second most important is the JSON one. So data scientists, they will get the data either in CSV format or in the text format or tabular format, right? Application developers and engineers, they will be getting the data either in JSON format or it is in the Parquet format. Sometimes you'll just have to read the schema also. Now, suppose you are reading the data from AWS or Redshift or maybe somewhere else. Without schema, you cannot infer which table it is, what are the data types, you cannot infer. So database or maybe data with a schema, if you are receiving separately, first you have to read the schema, store it, apply the same schema here, infer schema equal to true. Now, if you have an external schema which is provided by the client to you. You can use spark.read.schema and object store it as an object. Take that object and use it over here while doing infer schema equal to true. But this is not a CSV file, so schema would be applicable. So like mostly in the Parquet file formats, you will get data as well as schema separately. Right? So while reading the Parquet files, first you do a read schema and then you do a read data. Then you combine the data, read the schema and import the columns and types. Clear? Next, there is another way to read the file as well. Now, what we're doing here, first you are creating an application name. Why application name is required, and it's a best practice, right? Sometimes in a single Jupyter notebook, you would like to execute multiple projects, right? So different Spark projects, if you are working on, better to give always a name, always a name like app name, right? Always it's better to provide a name. Spark session, you are creating a separate session using a name, and you can just say something here. Just give a name, databases. Get or create. If it is existing, it will get the same information. You don't have to create it once if the name exists. Now, if it is not existing, it will create one. And it's going to be a Spark application, right? Then you can just user information also you can provide if you need. Now, these user informations would be required when you are establishing a JDBC connection. So read the dataset as a JDBC connector if you want to build. So you have to provide the URL from where it is requires to read. It can read from, let's take this IP, and you can provide user ID, password, etc. And the driver password also, if it is password protected, you can provide that. You can give a table name. So by default, the data would be stored in this table itself. Now this is just a PostgreSQL connection, right? Then URL, table name, properties. These properties is something which is here. The property contains the driver and a password associated with it. Okay. Now, so this I will execute, but it will not work because it's a dummy. It's a dummy database. Now, this is the structure how you will be establishing a JDBC connection using PostgreSQL. You will be reading the data from the databases. What is going to change? JDBC can be ODBC as well. Your IP and port can be different. User ID, password, it's a dummy thing now. Right now, it will not work, right? But this is the way you have to read data from external databases, whether it is Redshift, whether it is SQL, PostgreSQL, or it can be NoSQL databases like MongoDB, or it can be Snowflake, it can be any other location as well. But this is the common syntax that you are going to follow. Clear? Okay. Now, next is reading from HDFS. Again, this is also a dummy HDFS storage. You may get error while running this, right? But this is the way you have to use or read the files from HDFS system. So you have to execute, or you have to first initialize a Hive context. Now, initially when I did this Spark, you got two contexts, right? You get Spark context, you will get Hive context, right? Hive context would be required to write or execute SQL queries on Spark. Okay, so what we do from PySpark SQL, import Hive context, read the HDFS location where iris.csv is existing. So HDFS colon location of the HDFS. It can be AWS, it can be Azure, it can be any other enterprise IP and a port associated with it. So this is the address where the HDFS is located. And this is the file name. So you provide that SC
SC basically nothing but the Spark context which you have initialized before. So here I'll just put a comment. SC assumes that, otherwise you'll get error. SC needs to be initialized as Spark context. Okay, so the SC need to be initialized as Spark context, and then you can do sc.read text file using, I mean, CSV is also, you can read as a text file. You can use spark.read.csv also. You can do both ways, it works. So you created a Spark collection, which is, it's an RDD because you are using SC. By default, it is an RDD. Then you are initializing the Hive context, and this Hive context, and you are running a SQL query on top of Hive context. Fine. Any questions? Okay. Next one is transformations and actions, which we already discussed at a high level in the previous sessions. Now let's go to the function level. Transformations are like map, filter, then map, reduce, and it can be, let's take show. So these are all transformations if you want to do some modifications to the RDD. However, actions are like performing group by key, sorting, join, merge. These are going to be the actions. Now, once action is invoked, then execution happens. Until and unless the action is invoked, there is no execution. So no memory consumption, no computational resource consumption happens there. That's the difference. Okay. So next program, we are going to now do hands-on using all those functions. Any questions on this so far? Fine. Okay, so we'll start now. Optionally, I'm just introducing this logistic regression, but just in case we have to do any kind of machine learning application, so we may use it, but we can comment it out also. We don't need that right now. We can simply do a Spark session initialization. Next, what happens once the Spark session is existing, then we have to create a builder. So application name. So Spark session builder application name. So here we can just do data wrangling. Okay, get or create. Next, we are trying to read spark.read.csv, departure delays.csv. So this is the CSV file which is existing in the file store. And from where we are just trying to read this. Info schema true and header equal to true. So this is not required because it is already existing. So I'll simply do df and print date, delay, distance, origin, and destination. So this is my data frame, and here I will just do show tree. Okay. Date is now converted as an integer, which is not in proper format. So we'll think about how to format it, because the formatting is lost over here, because it is reading as a CSV file. In your CSV file, maybe the data format is in a proper way, but while transferring it, it is lost, right? So if I simply go back, departure delays data set, let me check it. Fields data. Data tables. This is the table again. In CSV, date is maintained. However, while reading it into Spark, the formatting is lost, and the column header is also not aligned properly. Right. So what we can do? Back to this once again. Df.show. Here, I just changed header equal to true. That's why the column header is in place properly, but the formatting is not there. So we'll think about it how to do it. Now, basic operations. Take two, it takes two rows and displays it as key and value pair. The date is this, delay is 6 hours, distance is 602 miles, origin is ABE, destination is ATL. These are the airport codes. Okay. And df.head also would work, and take also would work, which means this is a Spark data frame. On Spark data frame, you can do show, you can do take, you can do head. Three things you can do, and let's take show 3, take 3, and head 3. All three are working. If I change the data frame to RDD, which one will work, which one will not work? Show will not work.
Yeah.
On RDD, show will not work. Take will work. Head will not work. Okay. Collect would work on RDD. Collect 3, collect would work. Fine. That is why this head function, because we are coming from, let's take like a Python programming background, and we are used to write head functions on data types. Just this is the first couple of records, right? So that's why the people they built it. The data frame is built in such a way that at least people from other domains, when they're entering, they should not find it difficult. They should be able to execute the similar commands also, right? Now, print schema, it's about printing the data types. The first data type is an anomaly here, which is not in proper way. We have to figure out how to do that. The others, you can see integer is a delay in hours, which is fine. Distance is also integer, which is also okay. And the last two columns are string. Okay. df.show, this also we have seen before. Now we have to do filtering on top of it. Okay. Let's take the difference between the two. I'll remove the show here. I'll simply execute the filter. So what's the filter? df.filter. So let's take, if there is no delay in the flight, so show me all the dates, the destination and the origin of the flights where the flight is not delayed at all. If it is greater than 0, greater than or equal to 0, then there is a delay. If it is less than 0, it means there is no delay. Is that true? Right. Delay in negative number doesn't have a meaning, right?
Right.
If flight is now scheduled at 10 o'clock and it's delayed, so it will be 2 hours, so it's 12 o'clock. Negative means early departure. Scheduled like -2 means scheduled to 10, 8 a.m. departure. That's not a real scenario, right? Which means by default, some anomaly is entered in the data, which is not right. Basically, the negative numbers are not right. It's an error in the data, which we need to clarify with the business stakeholder. That how come the delay is negative, right? So we have to filter out that data. Delay is less than 0, or maybe you can do less than equal to 0 or less than positive number. And then you want to find out the delay number. If it is less than 0, what is that less than 0 number? Origin and destination. Okay. Now, is it an action or is it a transformation?
It won't change the data frame, I think.
It won't change. So this is a transformation, right? It's not an action. Now, transformation is completed, right? I executed this. It's completed, right? But how do I see the result? Did the execution happen here? This action.
We do a show.
Yes. That's why it is called a lazy evaluation. It is there in DAG now, but it's not executed. The moment I do show, now execution happens. Okay. So, Spark data frame, filter condition should be in bracket. After filter, what you do, you want to select multiple columns. Now, if you have to select multiple columns in Python, what's the command we typically use? We don't use select, right? We simply do df double square bracket, write multiple column names. If it's a single column, then single square bracket, write the column header, it will work. Right? But in Spark, you have to do a select. So select, it's not double square bracket, remember. Multiple columns, single square bracket. These small changes you should notice between Python and Spark. Right? Now then you do a show. On top of this, if you want to apply additional filters, you can also do. You can put a condition, any condition you can apply and extend this particular query. Finally, when you want to do some execution, then you do show. Right? If you don't want to do show here, just take this output and do some other calculations. You can just assign it to a new data. Okay. So that's why it's a transformation, but execution happens when you do show, collect, take, etc. The execution happens. Otherwise, no. Similarly, having additional filters. Now, this is let's take this is a different data frames used to be. But here, do I have high, low? No. This data frame doesn't have high, low. But this is another filter, but corresponding to a different data set where I think it is a stock price related data. Closing price, high and low price, etc. Same construct here. There is a Spark data frame. Filter is the function that you want to apply. The condition is required. So condition you can specify. This way also you can specify a condition. This is similar to pandas function. There are two ways to pass this function. So you can directly mention SQL way, which is column without double quote, delay the column name and less than 0. You can pass this way as a filtering criteria. You can also pass the filtering criteria this way, like a data frame, typical pandas data frame way. So here, DF, column header, and double quote. So this is your selection of a particular column, and then less than 500 condition, the criteria that you want to use. After that, what you want to do, you have to select only 2 columns, right? So notice the difference between the two. Here it is directly straight away column name and condition. Here it is selection and then condition. Both ways it should work. It's bad. Now, which one is optimal? It depends on the situations, like which column you are trying to replace, what kind of data set, how big the data set is. Depends on that. Okay. Now, this one we did last time also. DF dot printer, DF delay. Exactly, it is the same way. Greater than 0 and delay less than 100. If it's greater than 0, it can be infinite numbers. Less than 100, basically 0 to 100. Right? But delay 151 is also appearing here. It's greater than 0 and there's an and condition, right? There is one more condition here.
No, it is like not less than 100. Like
Greater than 0 and greater than 100.
and
So anything between 0 to 100 should not be selected. Okay. I'll remove it. This one we were trying. So you can see 6, 10, 28, etc. all less than 100. This is either it is greater than 0 or it is less than 100, then printed. So it will not show more than 100 scenarios. However, if I say not equal to less than 100 but greater than 0. Only so which is equal to your only greater than 100 scenarios. Okay. Now you can see the time differences also. It took 0.34 seconds. It took 0.53 seconds. You can see the differences. The processing time also. Right. So it is like using Databricks. It is another easier thing for you to figure out which syntax is taking more time, which syntax is taking less time on the same data set. And you can see the filters that is taking more time. Under what situations it is taking less time, you'll get to know that. Right. That would help you in making assumption, okay, why I'm using this function, why not this? If both of them are doing the same thing. Okay. But this number is not comparable because relatively this data set is too small. So we cannot interpret anything out of it. Only thing is we can take a note of things, but we can't conclude anything. To conclude, you need to really use like a maybe 20 GB data or 30 GB data kind of thing. Right? For that, what you have to do is you have to upgrade this edition, this Databricks edition. You can upgrade it. Once you upgrade, you can provide the credit card details. Storage cost is not much, right? And until and unless you are running it like large scale, maybe a gradient boosting algorithm. That will run by maybe $25. But otherwise, these things filter, show, apply on large data set, up to 20 GB data set. $1 or $2 would be the cost, not more than that. So you upgrade the Databricks account, you'll be able to load infinite amount of data, and you'll be able to design your own clusters. You can take a 5 node or 10 node cluster, take 20 GB of data, publicly available data, load it the machine on the cloud itself, then write those queries, and you can see the processing times. That experiment you can do. And simultaneously, just open the billing counter in another browser. Just keep seeing the real time, how much billing is happening. If you see too much billing is happening, just shut down the machine there. Detach the cluster and shut down the machine there. But I think, see, I did the whole experiment of up to 1 terabyte of benchmarking on AWS EMR only. And I spent around $16. We'll be taking break around 1 o'clock, right?
Normally you say like discussion and then.
Oh, okay. Sorry. Okay.
Class was conducted 1.5 hours, but then we are online for like 2.5 hours.
I'm really sorry because first initially we were trying to. Okay, fine. So let's take a break here.
Let's take a break till for 15 minutes on lunch break.
We'll take a lunch break now. Lunch ready. Lunch break. So let's take 10 minutes break. 15 minutes.
Normally we take
15 minutes break we are usually give. Till 12:45. No, I think when we spent initial
1 hour for this
internet, struggling with internet and okay, so let's go.
Shall I meet you then?
Okay.
Hello?
Yeah.
Sir has left for
No, I'm here. Tell me.
sir, what we can I can do like now both like can I do something like a stopgap to can I go with sign up that non-community editions now to work right? 'Cause
That will be available for 7 days. So please go ahead and do that. And once 7 days is over, then you can give another email ID and take another 7 days.
okay, sure.
Locally, it's working for you, right?
No,
Hello?
it didn't work for me actually. Same problem again.
Locally also it did not work.
No.
Shrikant, I'll share you a few links. Try that. I did, and it worked. For me, it was not working. So
You can share it. Sure.
yeah, I'll share. So this is what, right? If it works, we'll see this screen.
Yeah,
Correct?
correct. Yeah.
Yeah. So I'll share. It was not working for me also. I'll share you that. Just watch those videos and do the same.
Okay. So
Hello everyone. Start now. Hello, seriously.
Not yet.
Okay, please start now. Fine. So this is about filter condition, and then this is also another way to do a filtering. This is, I think, okay. The difference here is this is greater than and this is equal to some threshold.
Sir, you're not sharing screen.
Tell me. Display only yours.
Next change.
Okay. So post filter, if you want to do collect, then only you can see the results. Otherwise, no. So collect is again filter. It's just a transformation, but it is not telling you to show the results. Execution is not happening. To execute this, you have to put the collect also. Same thing, there is more difference. Now let's input another data set. This is called sales info. CSV. So it has 3 columns: company, person, and sales. Then schema. It gives you the company is string, sales is W, person is string. Now we'll be doing some group by and implicate. So these are all your actions. So filter is the transformation which we have seen. Now we have to do actions. Now here we are doing group by on company and printing the max value of it. Okay. But what is the output here? Can I do collect on this? Okay. So row is a company is output, and sales is maximum of sales. So by default, just look at 2 columns here which are string, person and company are string, and sales is numeric column or double. So if it's numeric, so max is being applicable on that column itself. And you are doing a group by on company itself. Right? So max is 750, so 350 max is plus. Then you can also do that. Arithmetic mean multiplication for each company, what is the average sales? Right? And you can do some operation also. Filling the sales for each company. You can do minimum, you can do maximum, and you can do count also. Now these are actions that we are performing. Then there is one more option to aggregate. And here, df.aggregate. Df is the Spark data frame. Aggregate is a function that I'm going to apply. And this function takes one numeric measure or numeric column, and it takes a measurement unit, which is maximum or minimum. So sales minimum show. So it's just to see the results or collect, you can do also. Then instead of show also you can do collect. The difference is that collect function you can see the row format data is. Show function it's a tabular view. That's the only difference. Similarly, you can also use aggregate syntax over there or aggregate API you can use that works on top of Spark data frame, sales, and sum of this. Into sum of this. Similarly, you can also do group by, but again you are creating another identity out of it. If you want to store this result somewhere so that you can perform some computations, first you do a group by on company. Get a new identity. The new identity dot aggregate function again on top of it, sales and sum it up. Right. So till now, what we did a group by on single column and numeric metric which is sales, and we did some minimum, count, max, average, all those things. Now, if we want to do a distinct count calculation, which is a very common task in data wrangling, like today suppose you get a data set of 20 GB and tomorrow you will get another 5 GB of data. You want to compare who are the repeated customers or repeated customer IDs present in both the data sets. Who are the unique customers that you would like to append to the previous data set. So mostly you need first a distinct count of first data set versus distinct count of the second data set. And those distinct count you have to compare whether there is an overlap or right. So to do that, and this function, this distinct count function, especially it takes a lot of time in pandas. If you are using set like normal Python set function, it gives you the unique values, which is quite easy. However, for a numeric measure, it takes time. String it is easy, right? So from PySpark SQL functions, we are using these. Mostly these functions can be leveraged in two different ways. On directly pandas data frame, you can use it, or on SQL-based functions you can use. So SQL library also contains these functions like standard deviation, speed, average, etc. Which one is optimal? So I would say SQL functions are optimal. Standalone functions are not optimal. Standalone functions, it works on the smaller data set, you can see the results over here. It's okay, but if you want to perform on a larger data frame, so I would suggest to go ahead with the functions library from SQL functions. Okay. From PySpark SQL functions, import distinct count, average, standard deviations, and you perform this. df.select a column which is sales and perform count, distinct count, and show the result. Okay. Same thing here, df.select average of sales, and you want to store it as a, you want to give an alias name, right? So now you are performing sales, count of sales, or something else, average. 5 different columns you want to create, so you want to give different names to the columns. Then column you can use for computations, but you want to store it, you want to give different names. So that you can differentiate which one is different from others. Right. So alias name also you can provide. Distinct count directly you can also perform. Standard deviations you can perform. Now, number formatting also it is important. So from PySpark SQL functions import format number Now DF select, it selects the column, standard division of cells you select or you compute it and give a name as standard division, standard deviation, and store it as ratio. Okay. Now you want to command it. So here you can see after decimal place there are so many digits. I want to reduce it. So select new column and do it 2 decimal places. And you store it as a different column. Now what happens? In this column is changed. It should be standard deviation. So after 2 decimal places, I will change it. This is about number format. So there is others also, format string also. So why and what are the use cases when do you need string formatting? Sometimes, let's say company name. Here we have company name and person's name. There can be leading spaces and trailing spaces as well, which will not be like you will not get to know that when you print the data frame or show the data frame. You will not be able to get to know that whether there is a leading space, white space, or trailing white space. So to me, it seems like the company column itself has some leading spaces here. Okay. But these spaces to the left, is it a white space? Is it a genuine space? That we don't know. Sometimes we have to do a truncation there. So otherwise, you will not be able to standardize the text. So to do the truncation, you can use a string format. Format number, format string. Both can be used. Okay. Now here it is order by. Order by one particular column. And you can decide the ascending, descending order as well. So by default, it is the ascending order. The sales values are being arranged. Now you want in descending order, you have to write this function descending. By default, you are not specifying anything here. So you just mention df.order by on this column and show the result. However, if you want to do a descending order, df.order by, then the column name you can mention this way and this way as well. But if you want to specify the order, you should use this way of writing. This way, if you are okay to go ahead with the default order, you can write it this way. If you want to change the default order, you have to write it this way. Here, cells, descending order, and show. Default is ascending. You can change it at any point of time. While changing it, make sure that the column is referenced to the data. Okay. Next thing is about missing value. What do we do with the missing value and how do we replace it? So using Spark pipelines. So any questions till now? Are we clear?
Yes, sir.
Okay. Now there is a sample CSV file which contains some NA values or not a number, so are null values. So these are called, you can see the null values over here. So these are called as missing values, and those missing values is simple, small, like very small data set, tiny data set, but it is easy. However, if we want to read it from a larger data set and we want to process it, it is a bit difficult to first interpret those values and standardize those values. Okay. So I'll come to that. We'll do a real execution of a proper data set and then do some values. Now you can do df.na.draw, Spark data frame, NA, and draw. Now what happens? The first employee has cells 0, null. Second employee, both the columns null. Third employee, 1 null. Now here you did not specify how many null values you should consider for dropping. Right? So sometimes what happens when you open up the Excel, explain it to you. So and be little careful when you are deleting this NA values. I'll tell you the reason what happens. Let's say this is your column 1, column 6. This is your column 1, 6. Now here you have some values. Okay. Now imagine you have only 12 records. For each record, some of the columns having null values. Now, if you go ahead with this NA dot drop, you will be left with only one row, right? Rest all of those will be deleted. Yeah. So you have to analyze how many columns I have to actually delete. Right. So think about like practical data sets where this could be name, this could be gender, this could be marital status, this could be income, this could be expenses, this could be profit. Right? So if there is a missingness here, name, I don't know, that's fine. But there is no point in dropping it. Right? And if expenses, income, and profit, I don't know, still there is a way to fill it. Income, so total, let's take average income is 2.83. So wherever there is a missingness, I can introduce 2.83. Right? Wherever there is a missingness, I can still go ahead and replace it with the average value of income. So now my data becomes complete. Similarly, expenses also I can take average 2.75. So this becomes my 2.75, and I copy it wherever there is a plan. I'll replace it. Okay. And this part average is 3. So I'll fill the value 3 wherever there is missingness. So now all 3 columns taken care of. However, somebody's name I don't know. There is no way to replace. Somebody's gender I don't know. There is no way to replace it. Marital status also I don't know. So I don't know what to put here in those 3 columns. Right. So if this is the scenario, I have to again handle this. Probably those 3 columns. I'll first do a missing replacement here. Then I'll see if all 3 are blank, then it makes sense. Right. So this is one which I would like to remove. It's not required. These 3 records also I would like to remove. And all 3 are blank. Right. Now let's take this is 1 means male, 2 means female. 2 means female, means female. Right. Now 1 box is only empty. So I'll put here unknown. This is I can put unknown. So wherever there is missingness, unknown I'll just put it. That's all. So basically what I have to do is here, I'm just trying to minimize the data loss. If I go ahead with df.na.drop, I'll be getting only one record. Now I'm trying to retain at least 8 records. Only 4 records I'm deleting, right? If I do this deletion, my data is now complete, right? So to do that, you have to introduce a threshold while deleting the NS. Okay. Now here it is, that's why if you introduce this one only you want to delete, this two you want to put. So you can specify threshold equal to df.na.drop threshold equal to t. So this part is there, this part is there. Now cells is there, so you can take an average and replace. This one is name, you don't know, just put it as unknown. Okay. So now this is another option, all, which means in our Excel sheet scenario, I'll just replace it. Let's assume that the entire row is blank, no data. Right? So when you are not specifying which one to draw, anywhere it is finding, it is dropping that record. When you put a threshold, it only drops like based on those, like 2 or 3, wherever, whichever record has 2 missing values, it will drop only that. If you say 3 missing values, that record will only get dropped. Okay. Threshold 2 means not necessary 2 max, up to 2. So 1 missing also will get dropped, 2 missing will also get dropped. If you say threshold equal to 5, up to 5. 1 will be dropped, 2 will be dropped, 3 will be dropped, 4 will be dropped, and 5 will also be dropped. Up to that threshold, it will drop. But manually, how do we check it? If you have a data set of like, let's take 20 columns, it's always possible to check. And practically looking at small data, it's not a problem. We can handle it. Okay, 2 nulls are there. Okay, right, threshold equal to 2. But when you are actually importing a data set from outside, you never know how many missings are there. Right? So to do that, you will be writing something called all. df.na.drop how equal to all. Entire row is missing, then only drop this. So in this scenario, the entire row is not having null. It is only these 2 are having null. Right? Employee ID still something is there. It's not null. If all the values are null, then only it will drop, otherwise no. So you have 3 options. Okay. Different from pandas. Pandas you will say drop duplicates or drop NA. Drop underscore NA function will use. So here we will be using part data frame dot function is NA dot drop action. Now how we can specify and show. Okay. Same thing here. If you want to subset based on the column. Now here you say, let's say income, expenses, profit. Average values are actually inflating the results. So there are so many missing lists. 2.83 is like replaced more than the number of times the values are there. So it's not necessary. And similarly, 2.75 is having more numbers in comparison to the actual data. These are the actual data, right? But the rest all others are fabricated, which is like a imputed value. It is not really right. Now what I'll do here, I'll say that if income, expenses, profit are critical information for the business. If something is missing, then I should not consider this or I should not assume anything on that. So if there is a null only on a numeric metric, then drop that record. The rest others keep it as it is. Rest others, if I don't know this, I can still go ahead and put it unknown. But if the critical metric or profit or expense or income, or maybe somebody's salary is not known, you are working on an employee database, then there is no point in creating that or keeping that record. So drop it. So You can specify if a particular column has any values, only drop that, and otherwise just keep it as it is. This is an additional option. Data frame .na dot drop subset on specific column cells. If cells contains missing values, then drop that record fully. Okay. Same thing here. You can specify the main column if it has empty. Just drop this here. Now, drop and fill the NA values. The filling the missing values here we fill it in 2.83, 2.75, etc. So we can do that. Whether we will be doing by zero filling, we can do that, or average also we can. Right? So DF, NA, fill. Zero we introduced wherever there is missingness here. Okay. And here we did fill NA string. And you know the difference here, when we say zero, it takes the input as integer and it says which column it is applicable. It did not put zero here, but it's a string. Now, when you provide a string value, it did not impute the values over here. It fills the only string values.
So, but this is applicable if there is only one field, right?
This is applicable if there is multiple fields also. Suppose ID column also there is 2, 3 null values. This field value also will go there. Wherever there is null on multiple string columns, this value will be there. Okay. Now there is one more option here. Fill unknown. So unknown is the string, and you can specify which column it should go. Right? Suppose here I want to do okay gender wherever there is missing. Okay, just replace it with male. So then here I will say if male column name is gender and just to replace it. Now if I'm indifferent, like whether it is name, gender or marital status, wherever there is missingness, I don't know that. So then you should put always unknown. So unknown is applicable for 3 columns. So instead of specifying unknown for this column, unknown for that column, you can simply use fill unknown. Wherever string column is there and it is missing, and it will replace them. Here. Fine. Any questions? This is about mean computation. So we know that. So simple functions, mean function here. df select mean of this column and get the value. So mean is 400.5. And this is also another way of selecting the mean computations. I'll store it as a mean value. Right? And then mean value contains, let's say, once the mean value is computed, what it holds. It holds one complete value, right? But it is not printing only 400.5. Right? So I have to pass it again. So to do a parsing here, what I can do here, just look at here. You can move it. Again, subsetting method, because here this 400.5, it is associated with 2 more objects also. Now, if I remove this indexing here, I'm getting row, average, sales, this. But removing this is the complete mean value that I'm getting. So I have to pass it because if I have to fill the NA values with averages, like this 2.83, I have to fill for this particular column. So I have to compute the average. of that particular column, right? After computation, I cannot simply, I mean, to me, I just, okay, I selected a column and computed the mean, and then I can collect and store it as a mean value. So then I should be able to use it as it is, right? So if I just write it, okay, take the mean value and do a subset, it will throw error. Because it doesn't know whether it is integer or it is a boolean or it is dictionary. There is no clarity on this. If I am doing some fill NA, which means it is should be a numeric or integer at least. Now this part is not numeric nor integer. So what I'll do here, I am first to do indexing. Again, do a passing on top of it. So I get the value. Now if I write this exactly instead of big value, it should work again. So while applying any kind of functions, first you have to see what is the result that is getting stored, how it is getting stored, and what additional thing I have to do to extract or reprocess, so that I can use it somewhere else. So now I get the numeric value, I want to replace it wherever there is a message. Same thing here, I can do, okay, df.na.fill, then compute the mean of this, then put a collect. So essentially what I'm trying to do now, these 3 steps I did manually. First to compute the mean, then do a collect, then assign it to something, then you can extract that value, then you do this. So similar step we are doing in one line here. Okay. Mean of the sales column you compute. Then you select that particular column. After selection, then you do, when you are before applying fill NA. So this part is your DF select, mean of DF cells. Then you do a collect. Collect function will give you the mean values of this particular expression. After that, you apply this passing times indexing and passing. Once you get the value 4.00, then it should apply fill NA. This part is basically what we did in 3 steps. Okay, and then you measure. Clear now? Any questions on this? Right. Next, dates and timestamp. This is important. So this Apple stocks ESP. So we have in one of the previous files, we were not able to read the date in proper format. Here it is reading it in proper format. Okay. But if I want to do some more modifications to the date and time object, I should do it. This is, I think, most complex part of it. This process is tedious. So you have to format it DDYY, DDMM, YY. Right. So let's see how we can do that. So selection, this is already. Select 2 columns you can do. Now this part is like including all the functions relating to date and timestamp. Okay. Why it is required? So this is required because of multiple reasons. One is feature engineering. In any kind of a machine learning task, you have to do a feature engineering, right? From any date and timestamp, how many features you can create? We have only 1 column. How many features we can collect? 43. 6. Right? Date of the month we can collect. Hour of the month, hour we can collect. Day of the year we can collect. Months we can collect. Year we can collect. Weekends we can collect. Weekdays we can collect. Day, night, evening, afternoon, early morning, all those things we can collect. Okay. Similarly, week of the particular year we can collect. Specific events we can collect, for example, weekend, night, weekday morning. So from date and timestamp, we can derive multiple columns, which will help us in creating features for our data modeling or machine learning. Right? There is a tool which is called feature tools. Anyone explore this tool? It's an open source Python framework for automated feature engineering. So you can provide only one single date and it creates multiple features automatically. So you could create more than 43 columns for a specific feature. Okay. At least like automatically these things will work. And how it works, so they are just given the graph. How it works. But this is something, right? So there is something called Spark entity sets. This is something which you will be requiring in your Spark. Okay. Now here, what they do, they code feature tools that they have PySpark. Within PySpark, you can use the pandas UDF function as PS. This is let's take some ID values, and this is the Spark data that is updated. Okay. The key functionality of a feature tools is available for use with a Spark entity set, and work is ongoing to add the remaining functionality that is available when using a pandas entity set. This feature tool is not compatible fully at the moment with the PySpark data. But if we have to do that, because anyways, for feature engineering, for ML task, you need to do that. There is no other option. So you cannot use this at this moment. In future, just for your knowledge, this is a tool which you can use in future in PySpark framework. Right? Once, so there are some limitations which currently they are working on it to reduce the conflicts. So once that is available, then you can bring in that feature tools here within Spark. That will become Spark compatible. And these feature creations, it should be done dynamically, automatically, and get added to the database in a very automated fashion. That is something which is required. Right? So how do we create it? So here you can just take a function, day of the month, provide the date value, and execute. So first date, day is 4th. 4, 5, 6. Right? Hour, which hour it is? 0th hour, which is like midnight, 0 to 1. Month, mostly it is January. Year, 2010, and subsequently you can see other years as well. Okay. Now, you want to store these new things that you are computing as a new column. What is the best way to add it in the data frame? The core of the primary data frame that you are using, it has only those columns: date, open, high, low, closing price, volume, and adjusted closing price. So 1, 2, 3, 4, 5, 6, 7 columns only you have in your data frame, Spark data frame. Directly you want to compute another column and store it here in this data frame. Basically, you want to update this at your data frame. Right? So what is the way to do? Because we said that it cannot be done. RDD once created cannot be modified by default, right? So what we can do here is we can create a new RDD by combining this new column to the old 7 columns. Right? So to do that, there is a specific way of doing this. Any other way it will not work. So the syntax has to be with column. Here, with column and give a name of the column. Once this computation is done, it should be stored as a new column called here. And this should be part of this data frame. The old data frame having 7 columns. Then what you do, you store it on a new data. And print. Now you get the year value. Right? So you remember that always you should use with column. Old data frame, dot with column, give a new name, and on which column you want to perform computation to get the result, and assign it to a new list. Now, on top of this, I want to add one more thing. Let's take the month of the year. Right, so I'll create one more line over here. I'll say months. Fine. Instead of year, I will say month function. Let's see the function. That's month. Right? Will this work?
You need to add to the new DF and store again, actually, the new value, because that is on the, you're doing on the old DF.
Exactly. It should be new DF and this should be something else. Okay. Now you want to do this one, so you can say new DF to get the marks. Now, if you subsequently keep adding new columns to this, then every time you add a new column, you have to expand this. That is where limit is. It's a limitation of PySpark. It's not like pandas, okay, you do something and assign it to a new column, then suddenly you add this new columns by just putting double square bracket, just keep adding. Quite simple, right? But here you have to create like this. Okay, so and imagine you have to add 20 columns. You'll be adding like this. Right. Now this new TF1, it becomes your core data set on which you are going to work. You don't need the interim data sets that is new DF. Then you have to delete it, right? Otherwise, it will be focusing to that data set.
Same variable.
The variable you cannot assign. Because RDT created only once. Even if you assign it to the same variable itself, both will be stored as two separate RDTs in two different locations. It will show to you, okay, the name, okay, this is what I stored and I'm seeing, but it's not the same object. It's a different object.
When you want to see the other one.
Latest one from the old ones. Old one will be overwritten because that is a separate location. That name object thing is now overwritten by this name. You will be able to see only the latest objects. But that doesn't mean the old object is deleted. It is still listed. And there is no way to access that. When you do delete, it will delete the recent database. So new DA will create 2 times. When you do delete, it will delete the first one, recent one. Again you do delete, then it will delete the second one. Right? Okay. Next one. So here, can we do a group by on this new data frame 1? Group by on here, compute the mean, then select the year as well as compute the average closing prices. Okay. Same thing here, you want to add a new column, result dot with column rename. Earlier it was average close. Now you want to change this column. What do? You cannot change it, right? Because by definition, RDD cannot be changed. But some relaxation is that the renaming column they are providing, right? You can at least rename the column. That's not a change in RDD, just a change in the name. So which is allowed. It was earlier, it was not there. In Spark, like 2 years back, it was not there. It was like, I mean, once you created it, it is gone. So you have to delete this, go back, do with column, create another column, and give whatever name you want to add. But this become like computationally overhead for the developers. You will remember. So then they released this with the recent. I don't know exactly when this came out, but this is a recent. This is not a very old thing. Column rename they are providing. Earlier it was this. Give a new name like this. So you should be able to change the existing RTT. Column names at least you should be able to change it. Okay. So then again on the same result, select here, format it. So any kind of column name change, formatting, all those things on the existing RTT is acceptable now. So here you can see after decimal there are so many digits. So I want to reduce it to up to 2 decimal places. So this is the format number on this column of 2 decimal places, and also known as just make it average closing price. Up to 2 decimal places. Okay. Then after that, little bit on the text data expression. So like any kind of IDF means. Inverse document replacement, IDF. So it's a process of converting the unstructured data to structured data. So there is something called TF, term frequency, IDF, inverse document replacement. So TF IDF is a transfer form. So which basically transforms your unstructured data to a TF IDF format. Okay. So formula for TF IDF is like total number of times the word is appearing divided by total number of documents that contain that particular word. Log of it. Okay. So TF IDF, it is applicable for unstructured NLP related data. This is the formula. TF stands for term frequency. I stands for document, J stands for I the document, J star. Document means, let's take articles. You have 3 articles: politics, business, sports. 3 articles, right? And words. So each article will contain some words. Now, I means each word uniquely present across 3 documents. So basically, you just do a tokenization for 3 documents. Take all the unique words present in all 3 documents. That becomes your I. Word 1 is I1, word 2 is I2, like this, so on and so forth, and IN. That is your I. Same means documents. So they have 3 documents: sports, business, politics, 3 documents. So J equal to 3. Term frequency means, let's take a word, let's take a travel time. Right? So I1, this word, and Jth document, what is the frequency? Let's say sports, Rahul Dravid mentioned 5 times. So term frequency for Rahul Dravid in sports document is 5. This becomes 5 multiplied by log of total document. So total document only 3. I have a document that contains the word Rahul Dravid is 1. So 3 divided by 1, log of it multiplied by TF, that is term frequency. That is called the TF idea. Yeah. Okay. Now why this is so? Because This is a process of normalizing the frequency of words. Right. So let's take politics. The prominent political leader's name, it is obvious that it will be appearing more than one times in the document. It is obvious. Similarly, sports. Sports person's name would appear obviously multiple times in the same article, or more than one sports person's name would be appearing, right? So sometimes this would inflate the calculations. In order to normalize that, what typically we do is we basically do the TF-IDF as a transformation method. That is a standard pipeline for all kinds of NLP related tasks. Yeah. So this is part of the feature engineering, where we get tokenizer. Tokenizer means each sentence will be broken into multiple words. Each word is called 1 gram. So if it is one word at a time, this is called 1 gram. If 2 words at a time, it's called 2 gram. If it is 3 words at a time, then it's called 3 gram. If it is 4 words at a time, then it is called 4 gram. Right? In NLP. Now, before computing this, these are called your stop words. A is to the it. These words are called stop words. I think those stop words will be cleaned up, should be deleted, right? So to do that, you can import the libraries. There is some error here. This is fine. First, to create a data frame. Now I'll make a truncate equal to true. What will happen here? Few words will appear for the sentence. Rest others will become dot. Basically, when you are reading a data set having sentences or more text, example, clinical data set or like pharmaceutical domains, or it is like drug discovery, like different kind of domains where you will have columns having no text. For example, adverse reactions of a drug. It's explained like vomiting, headache, etc. Somebody is explaining that, right, in a couple of sentences. So you can expect those lines. Similarly, customer feedback, Amazon reviews, positive, negative reviews, right? So those would be text. For each customer, you'll have structured it as well as a comment section. If that's the case, always make sure that your truncate equal to false so that you can see the text. You'll be able to completely read the text at least. Okay. Now, if you don't want to read and you are in the process of analyzing the data, then make it true. If you make it true, it is a compact version, at least you can see other columns also. If you make it false, it will be expanded, so other columns will go down and your view of this Spark data will be hideous. You cannot interpret anything, right? So what we'll do now, we'll use count vectorizer, we'll use TF-IDF vectorizer, and we'll use it hashing vector. These are 3 different kinds of formatting of the sentences. So your comment section column name is sample sentence. Input column is sample sentence. Output column you can specify because you want to break it into words by applying tokenizer, which means each word will be broken into as a token. Token means 1 gram. Okay, and you want to store it as tokens. Similarly, input column equal to words. This word you have taken. Output you can say count of words, and you can say count vectorizer. Count vectorizer means each word how many times it is present in which document. Right. Similarly, IDF is input column equal to count words that you are generating here, and output feature equal to IDF features. So basically, you are using the input from output from one column and using it as input in another column. Again, that output you are using as input in another column. So basically, you are taking the sample sentence and you are getting IDF. Okay. Now see the sample data here. Now this is your pipeline that you have established. Pipeline is any kind of your ML module is some machine learning class. That's correct. So pipeline concept you are aware of. So any machine learning task it goes through stages. Concept stages. So first it starts with reading the data, then feature engineering or feature transformations, then correlations or principal component analysis. Then after that, model building, then checking the model metrics, then doing cross validation, and finally model output. So all those stages you can put it as stages within the pipeline. Similar concept here in PySpark as well. So you can just include the pipeline. Within the pipeline, you can mention the stages. Now, first stage is get the sample sentence and break it into tokens. Then you vectorize it. Vectorize is nothing but the count vectorize you are getting. And compute the inverse document frequency, PFID vector you can compute. This becomes your ML pipeline. Now, ML pipeline fit we want to do on the sample data. Sample data contains your document name and the text. Now, that becomes your model. Okay. Now, this model building is entirely a transformation model building. There is no predictive model here, but this is data transformation model. Now, model.transform, you get the fit on the sample data. Now you want to do a transform. So transform, and here you can say truncate. Thanks for that. You got to read it. Okay. Fine. So we get the sample sentence, we get the words, we get the word counts, and we get the idea, values of which is part of it. Okay. So the model stages also we can interpret. First tokenizer gets applied, then count vectorizer, then idea. Okay. So through this, so like now we know how to do data frame based operations, filtering, group by, actions, some kind of transformations, as well as feature transformation for unstructured data like text. Any questions on this so far?
Yeah, there is a the pipeline, right?
Hmm. Okay.
Before that we are initializing. So here before pipeline, we are initializing all these tokens, vectorization idea. Here only it will do initialization, right? The actual call will not happen only at the pipeline.
Correct. So initialization happens here.
Okay.
Tokens, vector, idea, and we are using those initialized values to the object values.
Okay. Yeah, thanks.
Fine. So we'll take a break now. That's right. Yes. So we'll be back by. So the next thing is about a little bit task is there. So first we'll try to read a zip file. Any files that have an extension .cz, any kind of zip files, compressed file, you should be able to directly read it into Spark. Right? That is one to do activity that we have to do. Okay. We'll take a break now.
I will come back into.
3 o'clock, right? Back by 3.
Okay, fine. O'clock. Okay, fine.
Okay, thank you, sir.